Hello students, welcome back to Time Classes. Today we are going to continue with the next part of syllogism and we'll begin from where we left. So we were still to discuss one more aspect, one more kind of statement, and let's start right away. Now the statement is some politicians are not liars. If you get a statement which says some politicians are not liars, what statement should it be? You know already the four kinds of statements: universal affirmative, universal negative, particular affirmative, and particular negative. Now, this statement, it has got a sum in it, hence, it has to be a particular statement. Does it have a yes or no? No or not? Yes. Therefore, the statement is particular negative. Okay. So, the statement is particular negative, and how should we draw a diagram which would depict some politicians are not liars? Conventionally, I think most of you also will suggest that this should be the right diagram for some politicians are not liars. The part that is away from the intersection, this is the part that we are talking about. Some politicians are not liars. But truly speaking, this should not be used for depicting some politicians are not liars. I agree that this is also one of the conditions of some politicians are not liars. It meets that condition. But if you want to make a true diagram of what the statement is saying, then it should be something like this. Now, this is the group of politicians. All right. If this represents your politicians, then some would be what? A small part of this should be called sum. So we are referring to this small part of P, and it says that they are not liars. So this is away from liars. So let's have a group called liars. And what should we do next? Keep this little part away from liars. We should draw a bar between them to indicate that this part of politicians cannot ever meet the liars. Now, get one thing very clear. When it says some politicians are not liars, it means all the politicians can go into liars, but at least one part will stay away from liars. This is what this diagram is depicting. So, shall we consider this also to be a part of some politicians are not liars? Answer is yes. This is, although depicting no politician is a liar, but even one part of politician is away from liars. Therefore, this can also be taken to be true in case of some politicians are not liars. I hope you're able to understand this. All right, so moving ahead, it says all politicians are liars. When some politicians are not liars, can we say all politicians are liars? It will be wrong to say that all politicians are liars because some politicians are not liars. Now, before we get into that, we will try to figure another kind of diagram which shows some politicians are not liars. Now, we've got a politician category and we have got the liars inside politician. Is this depicting some politicians are not liars? This part of P is representing some politicians are not liars. I hope all four figures are true and you understand that all four figures are representing some politicians are not liars. So in this case, when I say all politicians are liars, it is not true here. It is not true here. It is not true here, and it is also not true here. Therefore, all politicians are liars cannot be possible because some politicians are not liars. Therefore, all of them can never be liars. All right. Now, let's look at the second one. It says all liars are politicians. All liars are politician. It's not true in the first one. Is it true in the second one? Not very clear. Is it true here? No. But what about here? Is it true that all liars are politicians here? Answer is yes. Hence, we cannot say that it is certainly false We can simply say that possibly true. Hence, the explanation for possibly true would be a dash. Third one says no politician is a liar. Does this indicate no politician is a liar, the first figure? No. What about the second figure? Does this indicate no politician is a liar? Not completely, but yes, this definitely shows no politician is a liar. And what about this one? No, this also does not show. Hence, it is not certain. Therefore, it should be represented with a dash. Fourth is no liar is a politician. When some politicians are not liars, then what is the condition of no liar is a politician? Can we say that no liar is a politician is true here? Answer is no. Can we say it is true here? Not very certain. What about here? Yes, no liar is a politician is confirmed here. But what about here? This is not confirmed here. Hence, your answer again should be represented with a dash. Next, when some politicians are not liars, then what is the position of some politicians are liars? Take the case of this one. Some politicians are liars is true here. Some politicians are liars is possibly true here also. Here it is not true, but here it is true. So in this diagram, it is not true. Hence, our answer has to be it is not certainly true. It is simply possibly true. Next, we talk about some liars are politicians. Now, some liars are politician, true here, can be confirmed, cannot be ascertained here, cannot be ascertained here, some liars are politicians, but here, yes, it can be confirmed. So, again, our answer cannot be certainly true, but possibly true. The last one says some liars are not politicians. So when some politicians are not liars, what is the position of some liars are not politicians? Yes, this part represents some liars are not politicians. What about this part? Yes, possibly. This part also represents that some of them are not. What about here? Yes, certainly. Some liars are not politicians. Absolutely correct. But what about here? This does not confirm. Hence, my some liars are not politician is not certainly true, but only possibly true. I hope you've understood all the four different statements and the conclusions of the other possible conclusions. What is true about them? Are they certainly true, certainly false, or possibly true? All right. Having understood the basics of the implications of various statements, we now move on to the questions from the handout. So please take out your handouts. The handout number is LAHO 1031607. So quickly take out your pens and registers and also the handout so that we can begin with the first question itself. The first question reads like this. It says, now look at the options given to you because these options are going to be there for all the first 10 questions. So understand the options very carefully now. It says if only one the first conclusion. We've got two conclusions here. So in this set of questions, we'll have two conclusions. We'll have to reply to how these two conclusions stand. All right. So if the first statement is true, then you mark A as your answer. If only the first one is true. If only the second one is true, then you mark B as the answer. If both of them are wrong, neither of them is true, then you mark C as the answer. And if both the conclusions are true, then you mark D as the answer. Now, please understand, we've given you these four conclusions. They are the norm. This is the kind of, options you will get. But please be very careful. Read those options carefully. They are most likely to be what we've written here. But just in case they are not, so please make sure that you recheck and see what A stands for and B stands for and C stands for and D stands for in your examination. All right, moving on. Now we see we are going to find out the answers to the two statements given here. All carpets are blankets and all spreads are mattresses. All right. Now, we draw the first Venn diagram for all carpets are blankets. If this is carpets, then where should blankets come? Outside or inside carpets? All carpets are blankets means that the carpets are inside the blankets. Therefore, we should have an oval that is surrounding, enclosing, engulfing the carpet. So, blankets engulf carpets, and therefore, this is the representation of all carpets are blankets. The second one says all spreads are mattresses. Now, do we know, can we have any relation of spreads and mattresses in this figure? No. So we'll have to draw another figure. So let's say this oval represents the spreads, then mattresses are supposed to engulf it, therefore come around it. Hence, this would show that all spreads are mattresses. All right. Now, look at the conclusions. Is the first one true that some mattresses are carpets? Remember, when the word given here is conclusion, it means that he is asking you whether it is certainly true or not. Conclusion word always means certainly true. If they use a word like possible, then it even possibly true could be taken as the answer. All right, but since the word is conclusion, so we only have to look at this being certainly true. Some mattresses are carpets. We've got mattresses here and we've got carpets here. Can we confirm that some mattresses are carpets? The answer is no. Therefore, the first one cannot be confirmed. All right, maybe true, but we don't know what is the relation between carpets and mattresses, or even we don't know the relation between blankets and mattresses. Therefore, we cannot confirm this. What about all spreads are mattresses? Can we say that all spreads are mattresses? Can this be confirmed? It cannot be confirmed here. It says spreads are inside mattresses. It does not confirm that spreads are of the same size of mattresses. Hence, we should not confirm this as the answer, and therefore both the statements are wrong. In other words, C should be the answer. All right. Please also notice here we are dealing with four terms here. So, as a simple rule, if the two statements that we are taking into consideration have four terms. Terms are carpets, blankets, spreads, and mattresses. So, if two statements that you are considering have four statements, then there you cannot derive an answer. All right. So, as a general rule, you should remember this. If there are four terms in a set of two statements, you can never get an answer. Right. So, because of that, also this conclusion is not possible. Hence, the answer is C. Moving on to the second question. Second question says, no sincere person is corrupt. So, in other words, we can read it as no sincere is corrupt. So, let's look at this. How should we draw a diagram for no sincere is corrupt? We draw a sincere category. Then we draw a corrupt category. So, what should we show? Should we show an overlap between them or no? Answer is no, because it says no sincere is corrupt. Hence, we have to show a bar between them. All right. Then it says that no corrupt is hardworking. So, hardworking are away from corrupt. So, if I draw this as hardworking, then what should I do? Should it overlap with corrupt or no? Answer is no. It has to be kept away from corrupt. Hence, I draw a bar between corrupt and hardworking. So, we've got a diagram, a basic diagram. Now we see that no hardworking is sincere. So here we are talking about a relation between hardware and sincere. We've got sincere here, we've got hardworking here. So can we confirm a relationship between hardware and sincere? What is the data given to us? That keep the hardware away from corrupt. Hardworking, sorry. Keep the hardworking away from corrupt. No relation has been confirmed between sincere and hardworking. If there is no relation between sincere and hardworking, then can we confirm that no hardworking is sincere? It won't be correct to say that they don't have a relation. Can we have some other way of representing the two statements that we have? The two statements, can they be represented in some other way also? Let's consider that. So we are going to draw another diagram to confirm that to confirm these two statements. All right, can we make different may make the diagrams in a different way? For first one says no sincere is corrupt. So let's say the first oval is sincere and the other is corrupt. So what do? We need to draw a line, bar between them, showing that they don't have any kind of overlap. All right. Then it says no corrupt is hard work. No corrupt is hardworking. So keep the corrupt away from hardworking. Does it say anything about hardworking and sincere? No. So can I draw my diagram in such a way where I keep away from hardworking, but I engulf sincere? Here I am showing the data given to me. No sincere is corrupt. Sincere is away from corrupt. No corrupt is hardworking. Corrupt and hardworking are also away from each other. But it is also showing that there is some overlap between sincere and hardworking. So can I confirm that no hardworking is sincere? Although this shows that no hardworking is sincere is true, but this does not confirm. Hence, I will not be able to conclude that no hardworking is sincere. I hope students you are able to follow this. All right, look at the second statement that we have. All sincere persons are hardworking. Here, not a single sincere is hardworking, but here, all sincere people are hardworking. Therefore, can I say that it is certainly true, these two statements? The answer is no. So, my answer in this case would be C. That means neither of the two statements can be said to be certainly true. I hope you've understood. Let's move on to the third question. Third question is talking of relation between mangoes and sour. So it says some mangoes are sour. So let's say we draw this as the category of mangoes. And what do we do with sour now? Should sour intersect mango? When it says some mangoes are sour, it means there is an overlap between mangoes and sour. Therefore, should we not represent sour in such a way where it shows some kind of an overlap? Which part are we talking about when we say some mangoes are sour? This part, the intersected part. All right. So the part in between the two is the part that we are referring to. Some mangoes are sour. Then it says all sweets are sour. So sweets are supposed to be inside sour. So will this be a true representation of the diagram of these two statements given to us? Answer is yes. All right. So here now we have to find out the truthfulness of the conclusions. The first one says some mangoes are sweet. There is no connection between mangoes and sweet. But can they intersect? Can we have a situation where mangoes and sweet intersect? Does it say that mangoes cannot meet sweet? Do our conclusions say that mangoes cannot meet sweet? Answer is no. No relation between mangoes and sweet is given. Therefore, can we extend this up to sweet? Maybe like this, mangoes and sour are interconnecting, and sweet is also there but mangoes is also intersecting sweet. Sweet is supposed to be inside sour. In this diagram also, sweet is inside sour, but mango is overlapping with sweet. So here in our second diagram, some mangoes are sweet is correct, and but in this one, some mangoes are sweet is not correct. The second is no mango is sweet. This is very true over here. Mangoes and sweet are not overlapping. But are mangoes and sweet overlapping here? Answer is yes. So can both be certainly true? The answer is no. And therefore, what should be the answer? Yes, absolutely. The answer is C again. All right, moving on. Question number 4. I hope you're getting the grasp of this and you're able to do these questions. Okay, anyway, if you have any doubts, we are always there to help you. So keep sending your doubts in case you have any. So, number 4 is talking about two statements again. All travelers are vagabonds. So, does this represent all travelers are vagabonds? Answer could be yes. And it also says that some travelers are James Bond. So we have to show a relation of travelers with James Bond. So can this be a true representation of some travelers are James Bond? Right? Yes, this should be. So can we say that some James Bond are vagabonds? Now, where are travelers? Travelers are inside vagabonds, all right? So, are we sure that travelers are overlapping with vagabonds? Yes, because this circle of travelers is also a part of vagabonds. So, there is a connect between travelers and vagabonds, all right? Now, he also said that some travelers are James Bond. So, travelers and James Bond also have a connect. Therefore, we are referring to this part of travelers with James Bond. All right. But is that part not also a part of vagabonds? Answer is yes. Therefore, is it confirming that some James Bonds are vagabonds? This part is actually a representation of travelers, James Bonds, and also vagabonds. This is the common area. Therefore, this should be correct that some James Bonds are vagabonds. All right. What about all vagabonds are James Bonds? Can we confirm that all vagabonds are James Bond? It is not being confirmed here, but could we draw another diagram? Now look at this diagram on your right. It says that these are not one but three superimposed ovals of the same size. All right, so there are not one, not two, but three. The first one is of the vagabond, the second is representing the travelers, and the third one is representing James Bond. So if all three are of the same size and they represent vagabonds, travelers, and James Bond, then will this be true? All vagabonds are James Bond. The answer is yes. But this is not confirming. Therefore, can I confirm the second one? No. But can I confirm the first one? Some James Bond are vagabonds. Yes, one part of James Bond is also overlapping with the vagabonds. Therefore, this is true in both the cases. Hence, my answer will be only the first statement is true, and therefore it should be A. I hope this is clear. Moving on. Question number 5. You can notice that the difficulty level is going up gradually. Next, please. It's talking about all students are Vidyarthis. So we've got students and we've got Vidyarthis around it. So this represents all students are Vidyarthis. It also says all students are Eklavya's. Is this diagram representing all students are Vidyarthis, students are inside Vidyarthis, and all students are Eklavya's. That means students are also inside Eklavya's. So we are talking about the students being inside Vidyarthis as well as Eklavya's. This is the area that we are talking about, right? So can we say all Eklavya's are Vidyarthis? Are all Eklavya's Vidyarthis? The answer is no. And can we say some Vidyarthis are Eklavyas? Notice this. This is a part which belongs to the students. It also belongs to the Vidyarthi because this is a part of Vidyarthi as well. And this is also a part of Eklavya. Therefore, this part is common to students Vidyarthi and Eklavya. So, can we say some Vidyarthis are Eklavyas also? Answer is yes. So, what about the first one? All Eklavyas are Vidyarthi? That should not be true. The second one should be true. And please also understand that this is also a representation of all students are Vidyarthis and all students are Eklavyas. Alright, so we could have this also. In this case, all Eklavyas are Vidyarthis is true, but in this case it is not true. Therefore, first cannot be confirmed, but the second one can be confirmed. Some Vidyarthis are Eklavyas. This can be confirmed. Therefore, the answer is B. Alright, moving on. Question number 6. Now, in question number 6, please notice that you have two statements. One of them is an affirmative statement and the second one is a negative statement. It's okay to start with the first statement. That's what we have been doing to show the representation of the statements. We have been taking the first statement and the second after that. But for your own convenience, sometimes you won't have to you may have to erase a part and then reconstruct the diagram. So to avoid all that confusion, always take the negative statements first and then draw a diagram of the affirmative statements. All right, this is a tool that I'm telling you. This is something that you keep in mind, that you always draw the diagram for the negative statements first and then take your affirmative statements. All right, so what I'm going to do is not going to make a difference, but it's only as a for your convenience that you will find this to be better. Otherwise, you may have to erase a little part to come to the negative statements. All right, so to avoid all that, we make the second statement, the diagram of the second statement first. All right, so no SAR is sweet. So this is the category of SAR, SO represented as SO, and this is the category of sweet. So we have to show that they are away from each other. Hence, what I do is I also put a bar between them. So this represents no SAR is sweet. Now we'll take the first one. No, all odor are SAR. So odor has to be inside SAR. Is this a representation of all odor or SAR? Absolutely. Hence, we'll consider this diagram. So now it says some odor are not sweet. Odor is supposed to be inside SAR. And SAR is not supposed to meet sweet. So if something is inside SAR or odor is inside SAR, will it ever be able to cross this line and go to sweet? Because it tells us that SAR is supposed to keep away from sweet. So whatever is inside SAR can never meet sweet. Hence, this becomes a true statement. Some odor, one part of odor will also not be able to go outside SAR to meet sweet. Therefore, some odor are not sweet becomes true. Now, what about the second one? No odor is sweet. Is that also true, that no odor is sweet? Can odor and sweet ever meet when SAR is supposed to be kept outside, away from sweet? Probably not. Therefore, what should be your answer? Answer is that both of them are true, and hence we mark D as the answer. I hope you're not confused in this. Very clear. If SAR is away from sweet and SAR has odor inside it, odor cannot ever mean sweet. Hence, D is the answer. Question number 7. Here also we've got one affirmative and one negative. We'll do the negative first to avoid any kind of confusion. So it says some nanos are not sweet. So we draw nanos, all right? But it says some nanos are not sweet. So one part of nano is to be taken for consideration. So one part of nano is supposed to be outside swift. And how do we represent that? with the help of this bar, that this little part of nanos will never be able to meet Swift. Alright, so this represents some nanos are not Swift. Then he also says that all nanos are Zen. So nanos are engulfed by Zen, or Zen is around nanos. Okay, so this represents our two statements. Very good. So no Zen is Swift. Zen has no relation with Swift. Are you sure? What has it asked us to do? Keep one part of nano away from Swift. As we have learned, all the parts of nano can go inside Swift, but one part of nano can never meet Swift. So, what does it talk about the Zen? It doesn't talk anything about the Zen. So, can the Zens overlap with Swift? The answer is maybe, because we are not asked or told anything about the relation between Zen and Swift. Hence, this may be possible. Can we look at it in some other way? For example, this is your nano, all right, and this is that one part of nano, and we draw a Swift. This little part of nano can never meet Swift. All right, so it is now showing me the second statement in the second diagram, and all nanos are Zen. So nanos are inside Zen. Could Zen be this big, engulfing both of them? Who can stop it? Nano Zen can take in all the Swift. It can take partially. It can take Swift partially also. In other words, we can show Zen to be intersecting Swift from here. So anything is possible because nothing has been confirmed about the relation between Zen and Swift. I hope this point is clear. If you've understood this, now we go back to the conclusion, no Zen is Swift. Can you confirm here that no Zen is Swift? Although you may be able to confirm here that no Zen is Swift, but can you confirm here? Answer is no. Therefore, no Zen is Swift is not certainly true. What about some Zen are not Swift? Now, some Zen are not Swift. Let's understand this. What is supposed to be away from Swift? This part of Zen, this part of nano. All right. Is this part of nano also part of Swift? Zen. Since nano is overlapping with Zen, so this little part of nano is also a part of Zen. So this part of nano, which is away from Swift, is also a part of Zen. So when this part of nano will be away from Zen, that part of Zen will also be away from Swift. One part of nano is away from Swift, and that part also has Zen. Hence, this part can never meet Swift. So this part of Zen will also not meet Swift. Same thing we can see here also. In fact, here we see that the entire, nano is inside Zen, and this little part also is a part of Zen. And if this part cannot meet Swift, then this part of Zen can also not meet Swift. Hence, the second statement is true, but not true in the first statement is not true. Therefore, your answer has to be B. Moving on quickly to question number 8. It says, since we've got another negative statement, I'll draw the diagram for the negative statement first. No left is a top. So we've got left and top, and we draw a bar between them. This represents no left is a top. Then it says all right or left. So right has to be inside left. This is what we made. So this is our diagram which represents no right or left, and no left is top. The conclusion is that some right are top. Are you sure that some right are top? Now, again, see that left is away from top and right is inside left. So, can right ever meet top? Can this ever meet top? The answer is no. Hence, this would be false. Some right are top. And it says no top is right. So, top and right will never meet. This could be true. Answer is right. Therefore, our answer here is B. I hope this also understood. Moving on. Question number 9. It's got no negative statement, so we can start with the first one. All months are weeks. This would be all months are weeks. So months is inside weeks. And it says some weeks are days. We've shown days, and days are overlapping with weeks. So this represents all months are weeks and all some weeks are days. Now we are asked that some months are days. Are you sure that some months are days? It is not true here. But can days be extended to overlap with months also? The answer is yes. In fact, it can engulf all the months also, because it is only talking about that days have some overlap with weeks. It is not confirming anything about an overlap between days and months. So we may draw this diagram to show the relation between days and months. We may choose to draw another diagram to represent days and months. This one is taking care of our first statement, all months are weeks. And now we also have days. What is days doing now? Days is overlapping with months also. Some weeks are days. So here we are trying to show some weeks are days, but while doing so, I am also showing an overlap between months and days. This is also a possibility where there is no overlap between months and days. This is also a possibility where there is an overlap between months and days. So both the possibilities are there. Therefore, can I confirm the first one? Some months are days? No. But can I confirm no month is a day here? Can this be confirmed that no month is a day? Here, days can overlap with months. Hence, this cannot be confirmed. In fact, I can also have a diagram which again is a set of three same sized ovals representing months, weeks, and days. And here also some months are days is true, but no month is a day is not true. Therefore, my answer should be C. Because some months are days is not true here, it is only true here. Therefore, my answer is both are not certainly true. Moving on, number 10. Number 10 is talking about some chairs are tables and some tables are furniture. So we've got chairs, we've got tables, and we've got furniture. All right. So can we say that all chairs are furniture? Does it confirm anything about chairs and furniture? The answer is no. But can we confirm? So we can't confirm that all chairs are furniture. But can there be a relation between chairs and furniture? Please remember, we can have a relation between chairs and furniture because it doesn't stop us from showing a relation. All right. And some tables are furniture. Some chairs are not furniture. Here it is true that some chairs are not furniture, but will it be true in all the other possibilities? The answer is no. Again, we can have a diagram which confirms some chairs are tables, my first statement, and also confirms some tables are furniture. In this case, all chairs are furniture is true, and some chairs are not furniture is not true. All right. So therefore, what can be confirmed here? All chairs are furniture. Can we confirm this? No, because it is not being confirmed here. Some chairs are not furniture is being confirmed here, not being confirmed here. Therefore, neither of them is the answer. Hence, C would be the right answer. All right. So we've done the first 10 questions. They are simple questions. They are more for practice. And now we get into some kind of difficult questions. Okay, question number 11 now. Question number 11 talks about digits and symbols. So it says all digits are symbols. So we've got digits and we've got symbols around it. Then it says all symbols are letters. Here we are dealing with three statements. So please see how we do it. And it says all symbols are letters. So we've got letters around it. All right. And he says, the third statement says that some letters are elements. So elements have some overlap with letters. Has he said that you should have an overlap with symbols and digits also? No. So I am only showing an overlap between letters and elements. But can they have? Can element have an overlap with symbols and with the digits? The answer is yes. Please keep it in mind, but this is a basic diagram that you need to draw. So can I say all digits are letters? All digits are letters here because digits are inside symbols and symbols are inside letters. Therefore, digits will also be inside letters. So this would be true. And it says that some symbols are elements. Is this confirmed here? No. But as I said, it can be extended here. So it is a possibility. All right. And it says all letters are digits. Letters and digits are of the same size. We don't know. Therefore, this is also not confirmed. So can we say only the first one can be confirmed? But before we do that, please also remember that we could draw one diagram. One diagram, in fact, four diagrams of equal size and representing digits, symbols, letters, and elements. All four of them of the same size could also be shown, but only one, the first statement, is true that all digits are letters. Because digits will always overlap with letters. All right. Question number 12. Question number 12 talks about, again, all affirmative. So we'll start with the first one. All fats are mats. Okay, we've got fats, we've got mats. So all fats are inside mats. Okay, then it says that some mats are rats. So mats have some relation with rats. Okay, and all rats have are cats. So rats are inside cats. So this is our cat category also. Okay. So I have to confirm that some fats are cats. Are you sure there is a relation between fat and cat? I have not shown it in this one. But can cat be extended up to fat? The answer is yes. But this is not essential. So I have not shown a overlap here. Second one says some mats are cats. There are some mats which are definitely overlapping with cats. Now, explore this. It says that mats have a relation with rats. All right. So mats and rats have an overlap. Okay. So this is the overlap that we are talking about. All right. Now this overlap, is this also a part of cats? Because rats are inside cats. Therefore, this overlap also represents cats. So, although we are saying that mats are overlapping with rats, but because rats are inside cats, so this is also an overlap with cats. Therefore, some mats are cats becomes true or not? Yes. Okay. Then we have some rats are fats. Some rats are fats. Rats are not intersecting with fats here. Therefore, we cannot confirm this. But the second one can be confirmed. All right. To show this, we could also have four statements, all of the same size. These three categories, all of the same In fact, four categories, all of the same size. Fats, mats, rats, and cats, and they would still be true. So, but what is certainly true here? Only the second statement. Some mats are cats. Next. Now I am not doing 13, 14, 15. I'll give you the answers to those questions. I am straight away jumping to question number 16 because I want you to, do the difficult ones also. So we now move to question number 16. Look at the statements given here. Out of these three statements, we have got one negative statement. Therefore, we'll take that up first. It says no folder is a drive. FO is representing folder and D is representing drive. So they have no overlap. Therefore, we show a bar between them. All right. The second statement, just the one above the third statement, all files are folders. So we've got all the files inside folders. All right. And then he says some papers are files. So now we show a paper category overlapping with files. Will that be all right? Some papers have an overlap with files. So we are talking about some area, probably this one. Some papers are files. Okay. What do we need to find out over here? Some papers are drives. Are you sure there is an overlap between papers and drive? Not in this one, but can there be an overlap between papers and drive? He has said keep folders and drives away from each other, put the files inside the folders and show an overlap of papers with files. All right. Can I do it in some other way also? Now I've got folders here. I've got drive here, no connection between them, therefore a bar between them. And I have the files inside my folder. All right, now look here. I've got the files inside my folder, and now the first statement, some papers are files. How do I show a relation between papers and files? This way. I showed an overlap of papers, and I also showed an overlap with drive. So, is this also a representation of my three statements that I have over here? Answer is yes. I have only, what I've done is I've shifted papers from here and put it here so that there can be overlap with files, which is supposed to be done, and while also overlapping with drive. This is not, overlapping with drive is not essential, but it is not ruled out also. Therefore, I can show it this way also. Okay, so now look at your conclusion. Some papers are drives. Are you sure some papers are drive? True in the second figure, but not in the first diagram. Therefore, we can't confirm this. What about some papers are not drive? Some papers are not drive is confirmed here. Is it confirmed here also? Now, please understand, folders are away from drive. Files are inside folders. Therefore, files will also not be able to overlap with drive. Okay. So, files are not overlapping with drive, but there is an overlap of papers with files. So, we are talking about this area. This area, which is file, folder, and paper. All those three categories. Okay. So, this area of papers, will it ever be able to go to drives? This part of papers, can it ever go to drive, which is also a part of files and folders? Folders supposed to be away from drive. Therefore, this would be true here also, that some papers are not drive. So, second is true. I hope you understand. All right. So, some papers are not drive becomes true. What about the third one? Some papers are folders. Are you sure some papers are folders? Papers are overlapping with files, and that portion is also a part of folders. Therefore, they will always continue to overlap with folders. So, papers and folders will continue to overlap always. They've done it here also in this part. Therefore, third is also true. Second is true. Third is also true. Fourth one says some drives are not files. There are some drives which are not files. As I told you, drives are supposed to be away from folders, and files is inside folders. Therefore, drives and files will never be able to meet. So, fourth one also becomes true. Hence, we can take it individually. Some papers are drive is not true because here it is not true, but here it is true. Therefore, it is not certain. Therefore, not true. Some papers are not drives is true, as I've already explained to you. Second is true. Third is true, and fourth is also true. Hence, my answer is D. I hope you've understood. All right. Moving on now to question number 17. 17 is talking about all flowers are roses. So flowers are inside roses. Then he says some roses are jasmine. So we are showing jasmines also. Some roses are jasmines. And it says all jasmines are red. All right. So then it says some flowers are jasmine. So there is a relation between flowers and jasmine. Are you sure? Flowers are overlapping with jasmine? Answer is no. But can they? The answer is yes, they can, but it is not certain. Hence, this will not be the answer. Then it says all red are flowers. Again, reds are also not overlapping with flowers, but can they? The answer is yes, they can. Then it says all flowers are red. Can flowers overlap with red? Answer is yes. There is no bar that reds and flowers can't meet. Therefore, that is also possible. And then it says that some roses are red. Are you sure some roses are red? Some roses are red. This means that we are talking about a relation of this one. Roses are interacting with jasmine. So this part is true for roses, jasmine, and red. So this part, roses are overlapping with reds also. Therefore, this becomes true that some roses are red. So my first is wrong, second is wrong, third is wrong. All right, but my fourth is right. So which option do I choose? Should I choose only 4? The answer is now. Before we know the answer, please also remember that I can have 4 equal sized ovals representing flowers, roses, reds, and jasmines. All right, so it can be shown like this also. But what is certain that some roses are red. Therefore, first is not true, second is not true, the third is not true, fourth is the only answer that is true, and therefore A should be my answer. I hope you're able to understand this. You need to practice some more questions and you'll get a better hang of this. This is the last question that I'll be doing with you because we are running out of time. So here we've got 2 negative statements. We'll take them first and then come back to the affirmative statement. It says no car is a bus. So no relation of between a car and a bus. And therefore a bar. And it says some buses are not trucks. So keep the trucks away from the buses, but at least one part. All right. So that's what I've chosen. I've chosen one part of buses and kept it away from trucks. Okay. And all scooters are inside cars. So I show the scooters also inside cars. Now it says no scooter is a truck. Truck is supposed to be away from one part of buses. Has it confirmed that's no relation between trucks and scooters? Okay. Can we make it in some other way? This shows no car is a bus. All right. And then it says some buses are not trucks. Some buses are not trucks. I've got the trucks inside the cars. Is it possible? Answer is yes, because in this case also, at least one bus is not touching truck. All right, so this is the representation of some buses are not trucks. I draw a bar between them. So this is confirming that some buses are not trucks. All right, and then I say that scooters are inside cars. Okay, so I've got this diagram. So it says no scooter is a truck. Is it true that no scooter is a truck here? Is it true here? Yes. But is it true here? No. Therefore, first is not true. Okay. Second says some trucks are not scooters. Some trucks are not scooters. In fact, all the trucks are inside scooters. There's no truck that is not a scooter. So this also cannot be confirmed here. Here it may be confirmed. All right. Then it says some scooters are not trucks. Can we confirm that some scooters are not trucks? It's confirmed here. It's confirmed here. So should we mark third as true? Before we say that, let's look at another diagram. This is confirming no car is a bus. We've got a bar in between, and it is also confirming some buses are not trucks. Is this representing some buses are not trucks? Look at this. I have this part of buses which are away from trucks. Therefore, this is representing some buses are not trucks. But what the trucks are doing is that they've taken cars inside them. All right. And in this case, can we confirm that some scooters are not trucks? Oh, I've got the scooters. Scooters are here. So can I confirm that some scooters are not trucks here? Here it is true. Some scooters are not trucks. But here, all the scooters have gone inside the truck. Therefore, this is not possible here. Hence, third is also not true. All right. And it says some scooters are not buses. Now, scooters are not buses. Buses are away from cars and scooters are inside cars. So, these scooters will never be able to meet the bus. Therefore, it is true here. Scooters are inside cars. Cars are away from buses. These scooters will never be able to meet the buses. This would be true here also. Scooters and buses cannot meet because cars are away from buses. All right. So it is true in all of them. Therefore, fourth is correct. If the fourth statement is true, which out of the options should I choose? I don't have an option which says only 4. So what should my answer be? The answer is none of these. I hope you've understood this also. So I'll now finish this and I'll give you the key to the questions that I have done as well as the ones that I have not done. So please note down this key quickly so that you can do the other questions and check your answers. In case of any trouble, you're always free to send your doubts to us and we'll make sure that we explain the topic in detail so that all your doubts are cleared. Thank you very much. All the best.